Okay, so we ended yesterday with a quiz, so there's nothing to review and no homework to go over, so we can jump right into new material. So I know that's what you guys all wanted to hear. Sure, why not? Hey, I like that attitude. So we've talked about this a little bit, but what does this mean? 8 to the third power, or 8 times 8 times 8. Perfect. Otherwise known as 512. Do you guys all know how to do powers on your calculator? Depending on your calculator, most of you have a button. It looks like this, a caret key. Some of you might have like a y to the x, or x to the y.
X to the square?
Well, that's just for second power.
No, then there's one that's just got a...
Oh, x with, oh, gotcha, x with a box there, yep. Yep, that's the one. So, the way you'd use that is just type in 8, press whatever key you have, and then 3 and hit equals. Should give you the 512. So let's try a couple. Oops, try that again. Oh, type in the 8, press that button, and see, look up on the screen. It might give you like a set of boxes or something. You might have to use your arrows to manipulate it. Yep.
Oh, yeah. After you put in the number, you got an
arrow up to get up to the box.
No, it jumps right up to the box.
Oh, it does. Okay.
But then you got an arrow right to get away from it.
To get out of the box. Okay. So let's try 2 to the power 11. See if you can come up with 2048. I'll race you on this one. Yeah. 5 to the power 6. 15,625. Yep. 3 to the power of 5. 243. You almost got me. It's like I explained to you guys before. Math is about patterns, and once you start to see the patterns, the calculations are extremely easy. Well, yeah, there may be some need for therapy involved before you do enough of that math. Find yourself huddled up in the corner in a little ball. Yeah. So then what happens if we have something like this? -7 squared. Punch that in your calculator, see what it comes up with. It's -7 times -7, which we know better be a positive 49, right? Because negative times negative is a positive. But what's your calculator say?
Syntax error.
Syntax error. I'll try again. 49. So you got positive 49? Some of your calculators will try to tell you it's a negative 49. Okay. Do you know why? If you enter it just like this, the squared, the power, according to order of operations, happens before the negative. So what this is doing is it's squaring the 7, and then it's applying the negative to it after it's squared. So when you enter it, you have to make sure you put parentheses around the -7 and then put the power of 2 outside the parentheses.
Yeah, I did that. It says syntax error.
It still says syntax error?
You got broken calculator, man. You gonna get some garbage over there?
Yeah. Try it again. If you have problems, I'll come over and help you quick. Still doing it?
No.
No, it works? No? I'll come over and take a look. But what happens if it's -7 to the third power? Because you got -7 times -7 times -7. Yeah. These two multiply to make a positive 49, but now you have a positive times a negative. It's going to be a negative 343. So let's have negative 3 to the power of 5. Positive or negative? Positive or negative? Negative. So 5, power of 5. So it should be a negative 243. Because you've got 5 of those negative 3's, right? Every pair multiplies up to be a positive. But you've got 1 left over because it's an odd power. If we did, let's see what we have here. Negative 8 to the power of 4, positive or negative?
Positive.
Positive, and it'll be 4,096. How about negative 5 to the power of 6? Positive, 15,625. So you get the point. Even power, the result has to always be positive. An odd power, if we're starting with a negative base or negative number, it can be negative. So with that in mind, wow, you're an optimist. Let's take a quiz.
Say that. With that in mind, it's time for a quiz.
On that note, we just had one yesterday.
I know.
I wouldn't give you another quiz until at least tomorrow.
Bruce forgot. He was like, "Oh, we might have a quiz tomorrow. We didn't get one today." I was like, "We got a quiz."
Okay, so all of our other operations have come in pairs. We had addition and subtraction. They came in a pair, and we actually talked about how those were really the same operation. One was going forward, and one was in reverse. And it's actually what we call inverses. Pick a number between 5 and 10. 7. Pick another number between 5 and 10. 4. Okay. Close enough to between 5 and 10. Throw it in there. What the heck? So if we take 7 and we add 4 to it, what do we get? 11. What if we want to get back to that 7? We're going to subtract 4. You can see here, adding 4 and subtracting 4 reverse each other. They undo each other. If we add 4 and subtract 4, we get right back to where we started. They're inverses. Multiplication and division are also inverses. Give me another number between 5 and 10. 6, another one. 9. 6 times 9 is 54. If I want to get from that 54 back to 6, what do I have to do? 5 by 9. So again, we see here, multiplying by 9 and dividing by 9 will reverse each other, cancel each other out. They're inverses. And we can go the other direction if we wanted to. If I had like 23 and I subtracted 8 would be 15. If I take the 15 and I add 8, I get back to the 23. So I still get back to where I started. Addition and subtraction are inverses. They undo each other. They reverse each other. Or over here, if I had 28 divided by 7, I would get 4. If I take my 4 and I multiply it by 7, I get back to 28. Multiplying by 7, dividing by 7 reverse each other, no matter what order they're done in. So now we just learned a new operation. The power, 7 to the power of 2 is 49. Once we get to that 49, how would we get back to the 7? Square root. The square root reverses the power of 2. But what if we had 6 to the power of 3? Well, 6 to the power of 3 is 216. Yeah, to get back to 6, to tell us that we're reversing a third root, it is put that little 3 in there. What's that? How do you do that on your calculator?
Yeah.
Depending on your calculator, it'll either look like this. It'll say n root, or x root, or box with the root symbol. Usually it's the second key. Wherever your power key is, it's usually a second key above your power key, especially if you have the caret key.
I have the carrot key.
You have the caret key? So on your calculator, you'd type in 3, and then second, hit that caret key, and then 216 and hit equals.
So isn't that just a regular 3 currently?
Nope. That's taking that as the index of the root. You got yours to work? Yours isn't working? Okay, I'll stop over quick and do it. Square roots and cube roots and stuff like that are difficult enough to do by hand that I do use the calculator. In fact, the algorithm, the process for doing a square root by hand, I would actually have to take a few minutes and look at the, I've got a book up here with it in. I'd have to take a few minutes and look at it to remember how to do it before I could even show it to you. At the end of class today, if there's time, I'll look it up quick and I'll show you. Or not. Not really horribly. You can live without it. You can die happy without being able to calculate square roots by hand. Die happier. Square root of 81 is 9 because 9 squared equals 81. But there's a hitch here. What's negative 9 squared? 81. Didn't we say that the square root reverses a squared? So if we take negative 9 squared to get 81, shouldn't we be able to take a square root and get back to negative 9? Yeah. We'll take a square root. There are always two answers. That is defined to be 9 or negative 9.
Why don't we only negative? Because that doesn't happen. I don't like that.
Good question. Like a fifth root. Try that on your calculator. See what happens.
What if you put that?
Try this though.
In parentheses.
That should always pop up the negative 5. But if we try to do the square root of negative 25, it'll give you an error, right? You didn't enter anything wrong. You can't take the square root of a negative. Because what do you square to get a negative? Yeah, nothing times itself will ever be negative. A negative times a negative is going to be positive. And a positive times a positive is going to be positive. There is no square root of a negative number because there's nothing that you can square to get a negative. At least not in real numbers. Now, if we were to get into an advanced algebra or abstract algebra, literally they made up an answer for the square root of negative, called it the imaginary number. Yeah, it's a fake number. It's imaginary. It's imagined. They made it up. And they made it up and they designed a whole system of algebra around that imaginary number. And believe it or not, there are actually engineering applications for it. When you get into electronics, imaginary and complex numbers actually do come into play. Because you have phasors and stuff like that, and if you have complex circuits, transistors, inductors, and capacitors within the circuits, you have current phasors and stuff like that. It's
We're playing Star Trek over there. Yeah.
none of that science fiction stuff. But anyway, what if I have the third root of a negative 64? Negative 4, that works. How about the fourth root of a negative 81? Why not? Yeah, we said before, any number to an even power will be positive. So if any number to an even power is positive, we cannot take an even root of a negative number. So we can't do that. So when we're dealing with even roots, we can only take even roots of positive numbers. So something to be aware of. Well, now that we've combined these roots and powers and all that good stuff in it, our next step is to combine the whole works together in things like this. There, something simple like that. Give that a shot. Get the feeling I'm like Peppermint Patty moving the football when you're about ready to kick it. You think you've got it? No, then it's gone. Let's take a peek, see how you did. Where are we going to start on this one? Yeah, we have our fraction bar, which is our first enclosing symbol. So we're going to start on the top of that in the parentheses. 12 times 0.4 is 4.8. Now on top, next we have is the squared, which will be 4.8 squared will be 23.04. And now 18.54 plus 23.04 is 41.58. On bottom, what do we have to do first? Square root of 2.25 is 1.5. And then? 68 times 0.08 is 5.44. Minus 1.5 is 3.94. Well, then we get to divide this mess, which is going to give us what? 10 point. We're going to round it to 2 digits, 10.55. Adding the 9.6 is 20.45. How many got that? Or close to it? Round off. What's that? 25? 0.15? Oh, you're right, it is 0.15. There. Sorry. I've been off all week. I don't know what it is. I think maybe it's because usually you only have 1 or 2 weeks before Labor Day, and having 3 weeks before Labor Day this year is really, it's really kind of nice because you get a break later in the semester. But after Labor Day, true. I have a really short day on Mondays. I have 3 hours of class. I'd rather have Tuesday off. Take it, just go. Forget about it. Screw it. Just a Tuesday. There we go. Try that one. Okay. Do you guys need more time? Yeah? Okay, I'll give you a few more minutes. Okay, on top here. We're going to have to multiply, or divide, sorry, 3.2 divided by 0.8 is 4. Plus 9 is 13.34. When we square root that to get got everybody at once. Square root of 13.34 is 3.65, we're going to call it. So that's what we have on top of that. How many you got to that point? Good deal. On bottom, where are we going to start? In the parentheses. And the first thing we're going to do is this right here. Then we're going to square it. So we got the division to do first. 8.48 divided by 1.6 Oops, clear that out. 8.48 divided by 1.6. 5.3, and then subtract the 3.12. Then square it. So I got 4.7524 in there. So 4.75 times or plus 43.1. So we got 47.8524 inside the square root, so we'll take the square root now. I'm going to show you a little trick that you can do on all your calculators. Rather than writing this down and typing it back in, I can just do this. Square root, second. Most of you have an A and S key. It's above one of your keys, but you can see it's above my negative key, it says A and S. Second A and S. Now it's telling the calculator to use the previous answer. So I don't have to write it down and type it in. Because if it's a big long one and it's rounded off, when I write it down and type it in, I'm going to get a rounded answer. So 6.92 I'm going to call that. So now I just have 14.7 times 3.14. Oops, not plus, times. And then I'm going to subtract the 6.92. So on bottom I get 39.24. So I'm going to divide those. 3.65 divided by 39.24. Now at this point, both of those answers are rounded off quite a bit. But we got basically 0.093. We got square root that. Second square root, second answer. 0.305. You did squared instead of square root if you got 0.0008. So 0.305, 0.31, somewhere in there.
And how come you had to break it down into so many sections?
I didn't have to. I just did it. I did it because I needed. Well, on your calculator, if you're careful, you can. The best way to do it to get the fewest mistakes is to do this whole top piece, then do the whole bottom piece, then divide them and square root.
So you make these in the word problem.
Not something like this, no. I would not. I wouldn't put something quite this bad on a quiz unless you guys really upset me. So behave.
No, these are on the test.
These are tests.
Yeah.
This is in your big book. Page 118. It's exercise 3-16A. Do the odds. Then on page 119, it's exercise 3-16B. Also do the odds. Page 121 through 123. Have you do 1 through 11 the odds. And then, just for fun, page 127. (21 through 31 the odds). I'm going to pause this and I'm going to look up that square root algorithm just to show you, just for fun. Sure. Give me a number between 50 and 100. Or 50 and 200, I don't care.
37.
Between 50 and 200. Let's go 137. If I want to do the square root of 137. Notice what I'm doing is I paired off, I started at the decimal point and I paired off the digits going both directions. So this first digit, this first set of digits, whether it's one or two numbers, I'm just going to take the square root of it. The biggest square number that's smaller than it, which would be 1. 1 squared is, well, let's make this interesting. Let's do this. Instead of doing 137, let's do 237. Well, still the biggest perfect square that's smaller than 2 is 1. 1 squared is 1, so I'm going to subtract to get 1. Then I'm going to bring down the next set of digits, 37. I take the number that's up here times 20, which is going to be 20. Now what I'm going to do with that 20 is I'm going to add a number to it. I'm going to multiply that whole thing by the same number. So if I let that be 1, it would be 21 times 1, or 21. And I'm looking for the largest number that I can make for that letter A and still be able to subtract it here. So if it's 25, if I let A be 5, that's going to be 25 times 5, or 125. So 5 is my magic number there. This is going to leave me with 12 here. I'm going to bring down my next two zeros, move my decimal point up, then I'm going to do 15 times 20 is 300. I'm going to do the same thing. Plus a number times that same number goes in here. Well, it looks like it's going to have to be 3. 303 times 3 is 909. That's going to give me 291. So 9 goes up here. I bring down the next zeros, and I keep going that way. If I double check this, the square root of 237 is better be 15.9 something. Oops, I did something wrong. Oh, because it wasn't 9, it was a 3. I put it in here, not a 9. So 15.3. So 15.3 something, and keep going like that. Not a real fun process, but it works. Okay, you guys have a great day.